Adiabatic isothermal polytropic curve for reciprocating compressor. So here we have drawn like this 1, 2, 3, 4, and I said like if we have isothermal system, it is like this. If you have PV per PV equals constant, this is PV per gamma equals constant, this is PV per N I am using polytropic, PV per N equals constant. So our mission should try to reach to this one, but PV equals C, but practically is not possible, so we follow PV per N. Okay, when we are talking about multi-stage compressor, actually what is multi-stage compressor? Multi-stage compressor like this. If you are compressing using single stage, okay, so P1, P2, P2, 1, 2, 3, 4. Okay, so what is happening because of high pressure issue? Because of high pressure issue, your temperature will be very high. Okay, temperature rise, T2 by T1 will be very high. So what you do? You create multiple staging. Multiple staging means one stage piston cylinder arrangement, then let's say one P1, P2, then you can create some heat exchanger, then again another piston cylinder arrangement, then again heat exchanger, again another piston cylinder arrangement. Okay, you can create multiple piston cylinder arrangement. So then after that P3, P4. So if you want to raise pressure from P1 to P4, so instead of going in one go, you give multiple pistons, and after every piston, let's say you reduce the pressure ratio in each piston, you cool down, you reduce the temperature, then again put into the second cylinder, reduce temperature, again second cylinder, third cylinder, fourth cylinder, fourth. So in that way you are creating multiple staging, and every stage you are removing heat. So in that way system compression, system performance is increasing. Okay, now it is single, this figure shows it is single stage compression, but if I use multiple staging, then what will I do? I will break this one, first stage, let's say two stage I am using. Okay, stage 1, let's say AB stage. Okay, after first stage I will be reducing temperature, so volume will be going down. Okay, so 1 to 2 dash to 2 double dash. Okay, first I will reach 1 to 2 dash, then I will reduce temperature. When I am reducing temperature, volume will be going down to 2 dash, then I will put that low volume fluid or air or natural gas into second stage. The second stage will be compressing. Okay, then I will be reaching to maybe 3 dash. Okay, so as I moved left side, this work is saved. Actually, this indicator diagram, this 1, 2, 3, 4, that area shows your work done. Now I got lower work done, my curve become like this. Okay, so this amount of energy got saved. Now if I want to create multiple stages, the same philosophy you can apply. Okay, multiple stage, like your first stage, then cool down again, then again cool down again. So this way you cool down and use, so you are saving energy every stage. Okay, this is the beauty of multi-staging. So if you go to any cycle shop where there is a compression system, so there actually you can see one cylinder and some machine element will be there. So there normally fins will be there. Okay, so fins will actually normally be reducing temperature. Okay, so that if they are reducing temperature, the whole system performance will be increasing. Now the formulation. How this formula? Work done in first stage, one formula N by N minus 1, P1 V1, P2 by P1, N minus 1 by N minus 1. Okay, this is the formula, and this is lower pressure end, or this A and B, higher pressure one, W2 equals n minus 1 P2 V2 P3 by P2 n minus 1 by n minus 1. Okay, so this naming I have done wrongly actually. PV, so it will be like this, then another system is going like this. Okay, so P1 P2 P3 P3. Okay, so this is V1, this is volume 1, then V2 P2 V2, this is P2. Okay, this is volume V2. So total work will be W1 plus W2. Okay, joule per cycle. Now if you are using intercooling, so intercooling W total will be n minus 1 P1 V1 P2 by P1 n minus 1 by n plus P3 by P2 n minus 1 by n minus 2. So minimum work in interstage. Minimum pressure actually P1 by P3. Okay, so P3 will be like square root of multiplication of P1 and P3. Okay, so there are several formula available, like theoretical volume flow efficiency, theoretical volumetric efficiency equals effective surface volume divided by swept volume. One, two, three, four. Okay, Vp. So eta V equals V1 minus V4 V1 minus V3. Okay, normally it will be 60 to 85%. Okay, work done W equals n by n minus 1 P1 V1 minus V4, because you have clearance. P2 by P1 n minus 1 by n minus 1. Okay, now we'll go to the problem. A gas compressor operating with an inlet pressure 2 bar absolute and inlet temperature 25 degrees centigrade. Compressor has compression ratio 3.5, the outlet pressure 8 bar. The gas being compressed using ideal gas law, heat ratio is given, R value is given. Okay, so now you have to calculate different parameters. Let's say T2 W you have to calculate. Okay, so P1 given 2 bar. So first you draw PV diagram. Okay, 1 2 3 4. P1 is given 2 bar absolute. T1 also given 25 degrees centigrade. P2 given P3 8 bar, again absolute. R value also given 8.314 J per mole per temperature. Okay, Cp is given, Cp not given. Cp we can find from 8.314 gamma by gamma minus 1. Okay, so this gives 29.094 J per mole K. Okay, W T2 equals T1 P2 by P1 power gamma minus 1 by gamma. T1 equals 225 plus 273 equals 298 K. So T2 is 298, 8 by 2, 14.1.4 minus 1 divided by 1.4 equals 424.35 K. So work equals Cp T2 minus T1. Okay, for ideal gas. Okay, now equals Cp value we know already, so 29.094 424.35 minus 298, so it is giving 37776.79 joule per mole. Now another problem, single stage reciprocating air compressor takes 8 meter cube volume air, 1 bar inlet. Okay, again intake pressure is given, P1 1 bar, so 1.1 into 10 to power 5 Newton per meter square, and T1 is given 30 equals 303 K or Kelvin temperature. P2 is given 6 bar equals 6 into 10 power 5 Newton per meter square. T2 equals eta V volumetric efficiency, gamma is given 1.3, work done you have to calculate. Okay, so Vc is given 5% of Vs. Okay, 1 2 3 4, so V3 actually equals V3, Vs equals V1 minus V3, K equals Vc by Vs, 0.05 Vs by Vs equals 0.05. T2 equals P2 by P1 per gamma minus 1 by gamma is giving 30 T1, so 303 6 by 1, 1.3 minus 1 1.3, it is giving 457 in 0.5 K equals 184.5 degrees centigrade. Okay, now eta V equals, one formula is there, 1 plus K minus K P2 by P1 1 by 1.3. So 1 plus 0.05 plus 0.5, 6 by 1 by 1 by 1.3, so it is giving 0.85 or 85%. Okay, work done equals in minus n minus 1 P1 V1 minus V4 P2 by P1 per n minus 1 by n minus 1, so this gives 1.3 by 1.3 minus 1, P1 value 10 power 5 and this 8, then it is given 6 by 1.3 minus 1 1.3 minus 1, then finally it is coming 1775 kJ per So power equals 1775 by 60 equals 29.6 kilowatt. So this is the result for this problem. Now this is the last lecture for this artificial lift course. What you have learned? You learned initially how oil and gas is forming, how this multi-phase flow occurring, what are the different formula, multi-component fluid, different formula, what is the IPI relationship. Then you learned your pumping systems, different pumping system, different artificial lift mechanism. Then you learned individual artificial lifts. Then you learned individual artificial lifts like SRP, ESP, PCP, gas lift, hydraulic lift, and surface pumps, compressors, then you let plunger lift, okay, and relevant information, electrical, mechanical, fluid mechanics, these systems. So to get more from this course, actually you have to do some extra study. There are lots of videos available in the YouTube relevant to each topic. For example, SRP, if you search, there are hundreds of videos and photos will be available on internet. There will be several lectures also from different universities, different enthusiast or industry lectures or field demonstration. Please try to go through those videos, and Wikipedia also there, you have ChatGPT there, so different sources there of learning. So if you want to learn, I have given only few things because there is limited time, I cannot teach everything for everyone. So I have given only few things, and remaining the larger aspect or broader aspect, if you want to know, then you have to go through internet and Google. You have several mechanisms, several ways to learn, okay. So you can explore all these things. So finally, if you are a student, you are searching job, or if you are already in industry, you want to enhance your career or you get promotion, so you have to learn, you have to focus on learning. So learning will help you to get more possibilities in your career, in your job. One more thing, sucker pump, ESP, PSCP, gas lift, all this selection method already I discussed, but again if I want to discuss, so if you go through individual lecture, there are positive, negative aspect already discussed there, but again if you summarize there, the sucker pump is a heavy surface unit is there, so offshore application little bit limited and flow rate limited, okay. Very high gas is there, then there will be a problem of gas lock or fluid pounding operations, okay. But for low flow rate application, gas well liquefaction, a small fluid flow rate is there, then SRP is very good. But for ECP, higher flow rate is there, and horizontal wellbore, vertical wellbore does not matter, slant wellbore does not matter, but SRP is having such difficulty of putting in horizontal systems, okay. But very long wellbore, offshore wellbore, SRP will fit, but ESP can go anywhere. But again, ESP also having difficulty like cavitation is there, you have electrical connections, motor protector issues are there. PCP, already the life is very low, like 5-6 months around, and but very heavy fluid, thick fluid is there, and you cannot use any other pump. So PCP is your friend, you use it, right? And gas lift application is very much versatile systems. When you got little bit lower production, you use gas lift, you reduce your flowing pressure, reservoir pressure fixed, flowing pressure is reduced, and you get more production, more fluid incoming into your bore, you are getting more production. So that way you are using gas lift system. And hydraulic system also, the hydraulic system jet pump is very low efficiency, but although low efficiency, but still people are using because it is having a certain issue, like its life is very long. Once you use 4-5 years, you cannot, you should not touch actually, okay. And hydraulic engine pump, it is like sucker rod pump, one extra engine system is there in the wellbore. So whenever you are using, you have to be careful how to use it, okay. And whenever you are selecting artificial lift, any type of artificial lift, first you have to know different types, options, what are the limitations, criteria. You should not use any artificial lift blindly, that will not increase your productivity, rather it will be consuming lots of money. After installation, you should not find, okay, this is not good for my wellbore. So better you study the different artificial lifting technique, what are the possible options are there, then study your wellbore, then try to mix up, then you decide which artificial lifting option will be there. So some advanced technique I did not include here, like multi-criteria decision making options are there. Multi-criteria decision making, like SRP can be used for A, B, C, D criteria, high pressure, high volume, low pressure, low volume, high temperature, low pressure, all this criteria you create. ESP also create criteria. So some cases SRP horizontal bore, no. ESP horizontal wellbore, yes. ESP high volume, yes. SRP high volume, no. So in that way, if you can create this yes no yes no yes no box and you can weight all the options, then finally it will roughly you can select certain artificial lift. Let's say out of 6-7 artificial lift, you can converge into 1 or 2. Then you can decide, you can talk to your company boss and you can decide which artificial lift will be best suitable for your wellbore or for your group of wellbores. Okay. So that way you can select artificial lift. So there are lots of software available, but before using the software, you should know different artificial lifting mechanism for the different issues, different problems, or the mechanical system, or the fluid mechanics issues, or the electrical issues. Then only you should select any artificial lift. And wishing you good luck. I hope you learned a lot, and this will enhance your career. If you're hunting a job or you're searching a job, I hope you will get a job through this. If you use this certificate, or if you're already in the industry and you want to enhance your career, I hope this will help. Thank you very much. Thank you very much for listening. Stay happy, stay beautiful. Thank you again. Bye.